guys, if you've ever had problem with an aspect of physics called projectile, or you have problem with finding the resultant of two forces, then this video is going to be super helpful to you, because in this video, in this section of Waec Physics 2015, question number 6 to number 10, we have questions on those topics and we are simplifying it. Don't forget, my name is Tutor Dami and I shall be simplifying that aspect of physics to you in a way that you will never have a problem with it again after watching this video. Now don't forget that if you learn something from this video, click on the like button. We have more content to send to you that will better help you understand physics. Now let's go to question number 6. The resultant force in a couple is what? Now, what is a couple? A couple is a place, is just a system whereby different forces are in equilibrium, like I have here. Now, look at this force. Force 1, force 2, and force 3 are tied at this junction, right? So they are said to be at equilibrium. They are said to be, you know what the word equilibrium is equal. That means that the forces are, the summation of the forces are equal. That means they are at equilibrium. And that's just it. Now let's see what will be the answer for all the forces that are at equilibrium. What it means is that since they are a couple, that means they are in equilibrium, and these are all coupled. The resultant of anything that is in equilibrium is 0. That means when you sum up all the forces, you will get 0, and therefore the answer to that question is simply 0. The sum of the forces is 0. It is not the sum of the forces. No, it is not the product of the forces. No, it is that because they are in a couple, and that means that they meet at a fixed point this way, the summation of their forces will become 0, and that's the answer to the question. Number 7, the slope of a straight line graph represents what? Now, have you ever done a straight line velocity time graph? A straight line velocity time graph before? No. You know, under motion 1, at the beginning of motion, we were taught something about velocity time graph. That means it is a graph that shows the relationship between velocity and time. Now, if you have forgotten, I will remind you. Now, this is the graph. This is the way it's slope. Now, this is my velocity here. The y-axis is my velocity, and the x-axis is my time, right? The slope that slows through the middle is this one. That is called the slope. It is called also the gradient. This slope is called what? It's called acceleration or constant acceleration. That means the body accelerated from here. You know, of course, you know that velocity over time is what? Is the formula for acceleration, right? So the slope of a velocity time graph is simply constant acceleration. So it's accelerated from rest this way. This is the slope this way, constant acceleration. Then it stopped here and went forward. This is not acceleration, this is constant velocity, because it's no more going sloping, it's no more sloping upward again. So it is now constant velocity this way. Then it slopes downward. This second slope downward is called constant deceleration. So the answer to that question is just uniform or constant acceleration. That means it is accelerating uniformly or constantly, and that is the slope of its velocity time graph, and that is the simple answer to the simple question. Let's check out number 8 now. Number 8 says a body is projected with an initial velocity u at an angle theta to the horizontal, right? The time taken by it to reach its maximum height is given by the expression what? Now this is a projectile question. Now under projectile we have 3 master formulas that you must never forget. Now once you know those formulas you have mastered, then you can answer any questions on projectile, and those formulas are just this. You must know the formula for the time of flight. The total time is 2v0 sine theta over g, where my v is my initial velocity, right? Now, and my g is my acceleration due to gravity. Now, this is the formula for total time. Okay, total what? Total time in projectile. And this formula can help you answer any question on projectile. These 3 formulas. Now, the next thing to know is the maximum height. That means if you know, projectile has to do with when you are launching something. Like if I'm kicking a ball, when I kick the ball, I launch the ball this way. This is a projectile motion. It is parabolic in nature or curved. Okay, it launches at an angle and lands. So now, the first thing to know is the time. the time it will take to fly to the maximum and to come down. That is the first thing to know, and that's this formula here. But the next thing to know is the maximum height. That means how far will it go? The maximum height. And that is given by u squared sine 2 theta over 2g. You need to write this formula down. It is very important. It is your saving grace when it comes to any question on projectile. Once you know this formula, you are no more scared. Okay, but if you have forgotten this formula, that's a problem. So now that is u equals u squared. H equals u squared sine 2 theta over 2g. And the last one is range. Okay, u squared sine 2 theta. Actually, h is u squared sine square theta over 2g. While my range is u squared sine 2 theta over 2g. These are the three formulas that surround projectile question any day, any time. Okay, now the question that is asking about time. The time taken to reach. Now you know this my formula for time is for the time taken to go up and to land. But the time taken to reach the maximum height only is half of the time. That means that for me to know the time, the total time is 2 u naught sine theta over g, right? But half of it means that I will divide that 2 by 2. I will cut it into 2. And to cut 2 into 2 is to cut out this 2. So I will be left with u naught sine theta over g. And that's my answer for half of the time. That is the time it takes to reach the maximum height only without coming down. So that means the total time is 2u sine theta over g. That is the total time. That is the total time. Time to go up and to come down. But the time to go up only is half of the time. And half of this one is divided by 2. Cut it by 2. You'll be left with u naught sine theta over g. And that's my answer. U sine theta over g. And that is the half of the time. That is the time it takes to reach the maximum height only. And that's the answer to number 8. C. Now let's check out number 9. Which of the following statements describe a body at a stable equilibrium correctly? Now, there are 3 types of equilibrium: stable, unstable, and neutral. Stable. Now, what is stable? It is a stable equilibrium when you push it and the body remains standing. But if you push it and the body falls, it is said to be at what? Unstable equilibrium. If it falls, now a little push, if the body remains the same, standing firm, then it is a stable equilibrium. But if you push it a little and it falls, then it is said to be as unstable equilibrium. But if you push it and it doesn't fall or stand, but it just spins, then it is at neutral equilibrium. It just spins at the same point. It's at neutral equilibrium. Now let's take it out. Now, which one is stable? That means the one that will not fall if you push it a little. Now we have person walking on a tight rope, like I have it here. This man is walking on the rope. Now you must have seen that game before. That people walk on rope from a high point. They'll be walking on the rope gently and gently. I've seen before when people perform different stunts on a tight rope. That person, if you push him a little, he will definitely fall. So that means he is not, that option A is not a stable equilibrium, because if you push him a little, he will fall. That's why I do this guy. Tunji is on the rope here. My Tunji is on the rope here, and you can see that he is shaking because it is not stable. It is not stable. So somebody walking on a rope is not on stable equilibrium, because a little push, it will spin over, it will fall over. Then the next one is a ball. The ball on a smooth horizontal table. Now you have the ball here. If you push the ball, will the ball roll? Yes, of course, it will roll over. A little push, it will roll. That means that the ball is not stable because it is circular, it is round. Anything around, if you push it a little, it will roll over. Now the next one is the ball resting on an inverted hemispherical bowl. Now this is the bowl inverted. If you push this ball a little, it will roll over. It is not stable. But if the last one is saying ball in the middle of a hemispherical bowl. Now if you look at this picture now, the ball in the middle of the bowl, if you push the ball will make it stand firm, because the bowl is balanced on the floor. If you push the ball will just roll inside the bowl. It will just remain the same. The ball won't let it go. The ball remains fixed at the middle. So this ball is stable. because the bowl is balanced, and the ball can't roll over because the bowl is balanced. So it is tightly fixed inside the bowl. It can't roll over, and that means that the only correct one is the option D, because it is inside a bowl. So let's talk about equilibrium. Stable equilibrium is a state in which a body tends to return to its original position after being disturbed. It is stable because it remains the same after you have disturbed it. And the only answer that's correct is D, ball in the middle of a hemispherical bowl. Let's check out number 10 now. Number 10 says, in a school compound, a girl was 40 meters due east from the laboratory to the staff room to submit a report. Then she turned and walked 30 meters due north to her classroom. Determine the magnitude of her displacement from the laboratory. Now let's draw that now. Now this is, you must know the 4 cardinal points first: north, east, south, west. Now the question that she started, this is the starting point. She walked eastward from the lab. She went eastward. That means this is my from the middle. East is this way. That means I will go this way, 40 meters eastward. This is the east. Then she went northward. North is up. You go up. Okay, and that is where she got to. So she went eastward to the staff room, and she went all northward to her class. And that is my diagram, right? 40 and 30, right? The resultant of the two force is just to say complete this triangle, and that completed part, that hypotenuse, is called the resultant, right? Now you know that if you want to find this side, you've gotten this side as 40 and 30, right? To find this side, the last part of a triangle like this, you have to use what we call the Pythagoras rule, and that rule says that r squared, this longest side, is squared, equals the 40 squared plus the 30 squared, and that will give me r squared equal 40 squared is 1,600, then 30 is 900, right? 1,600 plus 900 is 2,500. So now my r squared is 2,500, right? Now this square here, jump to this side, remove the square, it will become square root. It becomes square root of 2,500. So 2,500 is therefore 50 meters, and that is how you find resultants of any force, any day, anytime, with this kind of drawing. And that's the way to go about finding resultants. So the answer is just 50 meters, and that is the answer to the question. That is the magnitude, and that is the answer to number 10. So that brings us to the end of this video. Don't forget, if you learned something from this series, to click on the like button. We have more content to send to you that will better help you understand physics. Until we see next time, guys, take care of yourself, and bye for now.